All right. Welcome back. In this problem, we're going to find the diameter of the circle. Okay, you see the line segments we have in here, where they have them at 90 degrees, 13, 6, 18. If you want to solve this on your own, pause this video because I'm going to solve this in just a few seconds. Okay, so we need to know a couple properties of circles in order to solve this problem. First thing I'm going to do here is I'm going to draw a perpendicular line down here. Okay, and what I've created is a rectangle, so that's 13. Down here is going to be 6. I don't really need that 6. This is going to be 13 over here. Okay, for this length here. And then if the whole thing was 18, and that's 13, then this part down here is going to be 5. Okay, so let me erase some of these lines. All right, the next thing we're going to do is we have this theorem that if you have the perpendicular bisector of a chord, okay, so if I have a chord and then I have the perpendicular bisector of the chord, then that perpendicular bisector is going to go through the center of the circle. So I'm going to draw the perpendicular bisector of this chord here, and we know that that is going to go through the center of the circle. This part here is going to be 6.5. This over here is going to be 6.5. Okay. And because of this same rule here, we know that the bottom, this is 6.5 from here to here, 6.5 from here to here. So if I continue with this up there, this little part has to be 5. Okay? The next theorem we have in a circle is if you have two chords intersect each other like this, then the product of those segments are going to be equal to each other. So A times B is equal to C times D. So what I'm going to do now is I'm going to extend this line right here. Okay. And we know that this part here is 18. So 5 times 18 is going to be equal to 6 times this dotted segment here, which we'll call, in this case, x. 5 times 18 is going to be 90. 6x. X is equal to 15. So this part here is 15. All right, so let me clear this up a little bit. Okay, the next theorem we're going to use is the inscribed angle theorem that says if you have an inscribed angle, so let's say this angle here was 50, then this intercepted arc would be 100. Okay, so now what we're going to do is we're going to have the inscribed angle, but we're going to use this side that's 13. We're going to use this top line here, and then we're going to connect these two ends here. And if we notice, it has to go right through the center. The reason it has to go right through the center is because that's 90 degrees. And from this rule over here, if that's 90, then this arc has to be 180, which is a half of a circle. And now what I can do is I can use the Pythagorean theorem on this right triangle here, which is going to be leg squared, 13 squared, plus the other leg squared, 21 squared, is equal to the hypotenuse squared, which in this case we'll call d squared. D stands for diameter. 13 squared is going to be 169 plus 441 equals d squared. D squared equals 610. D is equal to the square root of 610. So D is about 24.7. Okay, there's our final answer. That was a great problem. I hope you enjoyed it. If you enjoyed this video and like to see more, please smash that like button and subscribe to my channel. I will see you on the next video.